all the properties of a parallelogram also hold good for a rhombus. All the properties of a parallelogram also hold good for a rhombus. Okay, so that is what this is. Okay, so two properties apart from all the properties of parallelogram, two properties of rhombus. First property is that the diagonals of rhombus are perpendicular bisectors of each other, and the second property is that the diagonals of rhombus bisect the interior angles of the rhombus. Okay, so with these two in mind, let us now see the problems. The first problem that I was about to solve, in fact, I have solved the first part of this problem, was that ABCD is a rhombus. In this question, it is given that ABCD is a rhombus in which angle BAC is 40 degree. So this angle is given to be 40 degree. Find the measures of angle ACB. ACB means this red angle that I have marked. Okay. So this red angle that I have marked here, let me just do it once again. So this angle was given to be as 40 degree. You needed to find angle ACB. So this angle you needed to find. Okay. And how would I find this angle? See that I have this angle as 40 degree. That means this angle must also be 40 degree. This angle must also be 40 degree because they are alternate angles. If you see this, these two are parallel lines, and this is your transversal, this line. So therefore, these two angles must be alternate angles. Therefore, it is 40 degree.
Good morning, sir.
Good morning. And you know that also once you get this as 40 degree, you know that the interior angles of that the diagonals of a rhombus bisect its interior angles. So if this is 40, this must also be 40, and therefore we have found this angle, this red angle that we had to find. Okay, so let us mark what angles we have found. And this time let's mark it with a lighter color so that we know these angles. So this is 40 degree and this is 40 degree. We have found. Okay, let us see the next question. The next question here is find angle ABC. So now our question is ABC. So which angle is ABC? This angle is ABC. This angle. Okay. So how to find out this angle? This is very easy because you have 40 degree here. This is a triangle here. So you can see this triangle. In this triangle, you know two angles. So you can find out the third angle, right? So this angle has to be the sum of the interior angles of a triangle is 180 degrees. So 40 plus 40. And say if I take this angle as x, then 40 plus x must be equal to 180. And therefore you can find out this angle. Let us proceed. We say let angle ABC equal to x. Or what you can also do is if you are not taking this triangle, there's another way of finding this. Okay. Can anyone tell me what is the other way of finding this? Anyone wants to try? See that this angle is 40 degree. This angle is 40 degree. That means what is the entire angle? 40 plus 40, 80. And this is your angle C. Adjacent to this angle is which angle? B. Angle ABC is adjacent to C. And you know that the adjacent angles of a parallelogram add up to 180 degree. So therefore, sum of this angle C, which is 80, and sum of this angle, which is ABC, they add up to 180. Therefore, 80 plus ABC, angle ABC, must be equal to 180. And therefore, you can find out angle ABC. Okay, so let us say this as x. Let us keep this as x. Number 2, I need to find angle ABC, so I call let angle ABC equal to x. Okay, so now what is, let us find out this angle, angle C or angle DCB or angle BCD. This angle C, you can either say angle C or you can say angle BCD or you can also say angle DCB. Angle BCD is equal to 40 plus 40 equal to 80, right? So therefore, if this angle is 80 BCD, then BCD and ABC add up to 180 because they are adjacent angles, because C and B in fact are adjacent angles. So therefore, angle ABC plus angle BCD equal to 180 degree. Why? Because adjacent angles of a parallelogram are supplementary. So ABC is x and BCD is 80. So therefore, what is x? 180 minus 80, which is 100 degree. That is, angle ABC is 100 degree. That is what we had to find out, angle ABC. So first two parts of the question are done. Let us see the third part. Let us mark the angle also, which we have found out. This angle we have found out. How much have we found out this angle to be? We have found out this angle to be 100 degree. Fine. So we have marked just in case we need it in future. Next, number 3. Which angle we have to find out? ADC. Let's mark the angle which we need to find out. This ADC, this one. ADC. This is very easy because see, we have already found out this angle to be 100 degree, right? Now these two angles are opposite angles of a parallelogram. They must be equal. So in one line you get your answer. So ADC must be equal to angle ABC, equal to 100 degree. Angle ADC equal to angle ABC is equal to 100 degree. Why? Because give you a reason. Opposite angles of a parallelogram are equal. So this is a one line answer. Okay. So now that we have found out this angle, let us write down this angle in pencil here, just in case we'll need it in future. So this is also 100. Fine. Next, fourth question is ACD. ACD is which angle? ACD is this angle. We have already found out this angle, ACD. That's it. So we simply write ACD is equal to 40 degree. As found in 1 above. Okay, so that's it. This is already answered. That is why I see I was writing in pencil. Okay, so next question is CAD. Let's see which angle. CAD. So you are required to find out this angle. Again, this is very easy. If this angle is 40 degree and if the diagonal bisects angle A, because the diagonal bisects the interior angles of rhombus, that means this angle and this angle must be equal. So if this is 40 degree, this must also be 40 degree. And the reason is that diagonal bisect the interior angles of a rhombus. So let's write it down. angle CAD is equal to angle BAC. Okay, BAC is already given. BAC equal to 40 degree, because diagonals of a rhombus bisect its interior angles. That's it. All questions answered. So this is also 40 degree. That's it. So all questions answered. See, I am writing all this in pencil. Okay, the light one that you see, these are all written in pencil. Now, why am I writing in pencil? So that I know in later, if I am supposed to use a particular angle, then I'll know that I have already found out this angle, then I can use this information. That is why in geometry, whenever you get your questions, if you get a figure in the question paper, if you get a figure, you have to redraw the figure in your answer sheet. And redrawing has a certain objective. Why do we redraw figures in geometry? We redraw the figures in geometry so that we can write all these in pencil. Okay, so that while doing the problem, we know which angle we have found out or which side we have found out. Okay, so that is the utility. Now, before I think I should proceed to the next figure. I think the next figure is rectangle. Okay, next figure will be your um, rectangles. Okay, in rectangles, first of all, we define what is a rectangle. Okay, now a rectangle is also a parallelogram, a special kind of a parallelogram in which one of the interior angles is a right angle. So we define a parallelogram in which one of the interior angles, any one of the interior angles is a right angle, is called a rhombus, a rectangle, sorry. It's called a rectangle. Okay, so this is the definition of parallelogram. Now we come to the properties of parallelogram. First property, property one. The first property of a, see all the properties of, let me write here, all the properties of a parallelogram, because it is a special kind of a parallelogram, therefore all the properties of a parallelogram hold good for rectangles. How many properties of parallelograms have I given you? How many properties have I given you for parallelograms?
So I think five. So five properties.
Five properties. So all the five properties will hold good for rectangles also. Okay. Apart from those five properties, these are the extra properties of the rectangles. The first property is that the diagonals of a parallelogram of a rectangle are equal. The diagonals of a rectangle are equal in length. The diagonals of a rectangle are equal in length. What does this mean? You have a rectangle. Okay, draw the diagonals. The diagonals are AC and BD. So in the rectangle ABCD, AC is equal to BD. The diagonals must be equal in length. In case of a parallelogram, the diagonals were not equal. In case of a rhombus, the diagonals were not equal. But in case of a rectangle, the diagonals are equal. This is one property. The next property is so you have only one property of rectangle. Okay, there's no other property because all other properties are properties of parallelogram. They need not be mentioned separately. See, what are the properties of parallelogram? Opposite sides are equal. In a rectangle, you have opposite sides equal, right? So when you're drawing a rectangle, this is 90 degree and you give these two also. So in a rectangle, you have opposite sides equal. Okay, fine. So this is holds for parallelogram as well as rectangle. Next is next property of parallelogram was the diagonal bisect each other. In this case also diagonal bisect each other. Okay. And the opposite angles are equal. Yes, the opposite angles are equal. This is 90 degree. This also has to be 90 degree. Okay. And similarly, these two also have to be 90 degree. Okay. So even that property holds. So similarly, all the properties of parallelogram hold for rectangle, except not except. In fact, additionally, this property is there. That is the diagonals of a rectangle are equal in length. Whereas in case of a parallelogram, the diagonals were not equal in length. Okay. So you need to have this very clear in your mind. This next we come to squares. Instead of solving any problem on rectangle, let us come to squares and then we'll go on to the problems. Write this first. Square. Now definition of a square. What is a square? Square is also a parallelogram. Parallelogram in which all sides are equal in length in which all sides are equal in length and one interior angle is a right angle. Is called a square. Okay. So square is a special kind of parallelogram in which all sides are equal and one interior angle is a right angle. So that is what the definition of square is. So let us draw a square. This is a square. All the sides are equal. Okay. One angle is 90 degree. That's it. This is a parallelogram in which all sides are equal and one angle is 90 degree. Let us come to the properties. All the properties of a parallelogram hold good in case of a square also. The first property of a square is that the diagonals of a square are equal, just as in case of a rectangle. Are equal in length. The diagonals of a square are equal in length. What does this mean? Let us draw a square. Draw the diagonals. So in the square ABCD, mark this to denote that this is a square. In the square ABCD, AC is equal to BD. That is, the two diagonals are equal. So this was the first property. Diagonals of a square are equal. Second property. The second property is that the diagonals of a square intersect at right angles. The diagonals of a square intersect at right angles. Now, if you remember your rhombus, this property is very similar to your rhombus property. Okay, where diagonals were perpendicular bisectors of each other. Okay, here also the diagonals of a rhombus intersect at right angles, and of course they bisect each other because a square is also a special kind of a parallelogram. Okay, so this angle must be 90 degree. Okay, so this is in the square ABCD. In the square ABCD, you have AC perpendicular to BD. Okay, so this is what the second property is. Now, what I would like you to another property here is, yes, another property of a square is very similar to that of rhombus. The next property, property number 3. Again, property 2 and property 3 are very similar to your rhombus. That is, the diagonals of a square bisect its interior angles. Interior angles. So what does this mean? This is a very important property actually. For a square, this is a very important property. You have the square. Suppose they intersect at O. Then what I said that each interior angle of a square is 90 degree, right? And of course, this according to this property, that the according to this property, the diagonals of a square bisect its interior angles. If the diagonals bisect its interior angles, then what, these two angles must be equal. Similarly, these two angles must be equal. Similarly, these two angles must be equal. And similarly, these two angles must be equal. If the diagonals bisect the interior angles of a square. But what we see is that this entire angle is 90 degree. And if these two angles are equal, then this must be 45 degree and this must be 45 degree. 90 divided by 2. This must be 45. This must be 45. This must be 45. This must be 45. 45. 45. Okay, so this is what your property is. So in the square ABCD, in the square ABCD, you have diagonals, diagonal AC bisects angle A and angle C. Diagonal, let me give a comma, diagonal BD bisects angle B and angle C. So third property is a very, very important property of a square. And if you see, property 2 and property 3 are very similar to your rhombus, and property 1 is very similar to your rectangle. Okay, so somewhat a mixture of rectangle and rhombus. A square is a mixture of rectangle and rhombus. All the properties, so this covers all the properties of a square. I expect all the properties to be by heart.